Today's lesson is Welcome to the Age of Fusion. Hi, everybody. My name is Roger.
Hello, I'm Kiki.
And today we're going to talk about nuclear energy or nuclear power. And of course, when we mention that, people get scared. Oh, no. If there's a nuclear accident, what's going to happen? Especially here in Taiwan, if there's a nuclear accident at one of the nuclear reactors, there could be radiation all over the place. So nuclear fusion is a new kind of nuclear energy that we know about, but we haven't been able to reproduce it.
Right. And when we see the word in the title, fusion, it's usually when two things are added together and they become something else. They produce a new thing or they produce a new effect of some sort. So I guess today we're going to be learning about nuclear fusion.
Yeah, are we welcoming the age of nuclear fusion as a source of energy? We'll find out what that's all about in today's lesson. Let's get to it. Let's listen to the first part of our lesson, and then we'll discuss it.
Welcome to the age of fusion. For decades, scientists struggled to achieve a feat that seemed almost impossible: replicate the way the sun and other stars produce energy. And finally, last December, researchers at the Lawrence Livermore National Laboratory in California found a way to recreate this process, which is known as nuclear fusion.
大家好，第一部分我们可以看到动词 replicate， 它指的是复制、重复、使重现或是再生。例如 After his last gaming video went viral, Danny hopes to replicate his success by releasing more. 在他上一支玩游戏的影片在网络上爆红之后 ，Danny 希望透过发布更多影片来复制成功的模式。或者 Sandra aims to replicate the productivity she had at her old company once she starts her new job. Sandra 设立目标，等她开始新的工作时，可以再创她在前公司时的生产力。接下来我们看到单字 laboratory， 它是名词，指的是实验室。例如The scientists worked for days in the laboratory. 那些科学家们在实验室里工作了好几天。或是 Laboratory studies have found that this drug is safe for human use. 实验室研究发现这种药物给人类使用安全无虞。
Okay, so again, we're talking about fusion, and as Kiki said, that's when you take two or more things and put them together to make something new. Now, if you talk about nuclear power, the kind we're most familiar with is nuclear fission, which is when you actually split an atom apart. Like at nuclear power plants, they usually split uranium, I believe, and when you do that, you create a lot of energy, which can boil water to run power generator and things like that. But unfortunately, you will be left with lots of radioactive waste. So a lot of people are opposed to nuclear power or nuclear fission, but this is a different kind here, nuclear fusion, and our article will explain that concept to you.
For decades, scientists struggled to achieve a feat that seemed almost impossible: replicate the way the sun and other stars produce energy. So for many years, scientists, they wanted to achieve something. They wanted to achieve a feat. A feat is a type of challenge that's so hard, and they want to achieve something that people think might be impossible. So they tried to replicate the way the sun and other stars produce energy. Replicate is to reproduce, to recreate something that might happen naturally. So scientists, they want to work in their labs to try to copy something that happens in nature. They will try to replicate it in their labs.
Right, so of course scientists know that the sun is powered by nuclear fusion with lots of hydrogen atoms coming together to form helium. But the trick is to reproduce that on the Earth. Of course, in the sun there we've got millions of degrees in temperatures, and that can bring about nuclear fusion. But it's not that hot here on the Earth, so we need to reproduce that heat artificially. We need to replicate to copy, to redo the way the sun and other stars produce energy. And finally, last December, researchers at the Lawrence Livermore National Laboratory in California found a way to recreate this process, which is known as nuclear fusion. Okay, so we've got a research institute in California called the Lawrence Livermore National Laboratory. A laboratory is just a place where scientists conduct scientific experiments. Of course, in high school or in junior high, you probably had your chemistry class and you went to the laboratory, which had the test tubes and the Bunsen burners and all that fun stuff, so you could create different things in the laboratory to conduct experiments yourself.
And to recreate something, like we said, is to copy something that happens naturally, or you want to copy somebody's behavior. So you try to recreate it. You make it again in your way, or you try to find out how you can make it again in a different scenario or in a different situation.
Right. And of course, if you recreate this process, you duplicate it on the Earth. So yes, indeed, we want to combine hydrogen atoms to make helium and produce a lot of energy as a result. Okay, that brings us to the end of the first part of our lesson for today. Let's listen now to the second part.
More specifically, nuclear fusion occurs when two atoms press together so tightly that they combine into a single atom, creating a burst of energy as they do so. The Livermore scientists used 192 lasers to heat a ball of hydrogen about the size of a peppercorn to millions of degrees Celsius. The result was exactly what they'd hoped for. The hydrogen atoms produced a fusion reaction, releasing a flash of energy, and more importantly, doing so with a net energy gain. That is, the energy produced was greater than the energy used to cause the reaction.
第二部分我们看到名词 atom， 它的意思是原子。例如 Mr. Adams used a model of an atom to teach his students about matter. Adams 老师用原子模型来教导学生物质的知识。又或者说 Atoms are the basic building blocks of all things. 原子是所有东西的基本构成要素。接下来我们看到单字 laser， 它是名词，指的是雷射。例如 Lasers are used in a wide variety of medical procedures, including eye surgery. 雷射被用于各种医疗手术，包括眼科手术。再举一个例子 Unfortunately, my new laser printer does not work with my old laptop. 不幸的是，我的新雷射印表机无法在我的旧笔电上使用。
Okay, so more specifically, to give you some more specific details, or to give you details, nuclear fusion occurs when two atoms press together so tightly that they combine into a single atom, creating a burst of energy as they do so. So an atom, of course, is a substance of nature. Atoms, of course, include things like hydrogen, helium, lithium, etc. Those are all atoms, and when they combine with other atoms, they become molecules. And the Livermore scientists used 192 lasers to heat a ball of hydrogen about the size of a peppercorn to millions of degrees Celsius. Now, hydrogen is the first atom or the first element on the periodic table of elements. Hydrogen, I believe its atomic number is 1. And they had a ball of hydrogen atoms, and altogether they were about the size of a peppercorn, which is really, really small, a round object that's about 1 or 2 millimeters across.
Right, and a peppercorn is usually what we have with our soup, or you can put it when you cook. You can use it as a peppercorn itself, or sometimes you would like to grind it up into little pieces so that the flavor comes out more. And we also see in the beginning of the sentence lasers. So nowadays we use lasers in a lot of situations, and laser is usually a beam of light. So there's a lot of laser surgery that goes on now. You know, when you have LASIK surgery, they also use lasers. And in this case, they use these lasers to heat up the little peppercorn-sized hydrogen, and they heat it up to millions of degrees Celsius.
Exactly. So it was really, really hot there. You did not want to be at that spot there. Of course, Celsius is the most common form of measuring temperature in the world. In the United States, they still use Fahrenheit, but here in Taiwan, of course, we use Celsius, sometimes just simplified as the letter C. And the result was exactly what they'd hoped for. The hydrogen atoms produced a fusion reaction, releasing a flash of energy and, more importantly, doing so with a net energy gain. So that's an important breakthrough there. In the past, of course, they probably spent lots of energy trying to get these atoms to fuse together, but the energy they got was not equal to the energy they put into it. But finally, we have an excess of energy. We have a net energy gain. That is, or to be more specific, or to simplify things, the energy produced was greater than the energy used to cause the reaction. And that seems to be a breakthrough, although I don't think you're going to see fusion reactors anytime soon.
Right, and that comes to the end of part 2. Let's have a listen at part 3.
This net energy gain gives the scientists hope that fusion could someday be scaled up to help solve the problem of climate change. As fusion produces limited carbon emissions and nuclear waste, it could potentially be a source of clean energy. And while the ultimate goal of large-scale nuclear fusion plants powering our lives remains far from realized, the recent breakthrough raises hopes for a greener future.
第3部分我们看到单字 potentially 这个字是副词，它有可能的、潜在的意思。例如 If the dam fails, the entire valley could potentially be flooded. 如果水坝故障，整个山谷可能会被淹没。或是 This contract could potentially make the company millions of dollars. 这份合约可能会让公司赚进数百万美元。另外，去掉这个字的字尾 ly， 就会变成形容词 potential。举例来说 Officials are aware of the potential risks of the project. 官员们知道这项计划的潜在风险。再举一个例子 A 10% discount was offered by the store to encourage potential customers to purchase items. 为了鼓励潜在的消费者购物，该商店寄出了9折优惠。最后，我们看到单字 breakthrough， 它是名词，意思是突破或是重大进展。举例来说The police had a big breakthrough that allowed them to finally solve the mystery. 警方有了重大突破，终于解开了谜团。又或者是 The two countries achieved a breakthrough in their peace talks. 那2个国家的和谈取得重大进展。
Okay, moving on now to part 3 in today's lesson. Let's continue to talk about nuclear fusion. This net energy gain gives the scientists hope that fusion could someday be scaled up to help solve the problem of climate change. So we have this net energy gain. In other words, we got more energy than we put into it at the beginning. And scientists now are hopeful that fusion could eventually improve by leaps and bounds, and eventually it can be scaled up to help solve the problem of climate change. If you scale something up, of course, you increase the value of it. You increase the amount of something. For example, if you manufacture a certain product and you sell it on the market for $100 NT, and then people like it, they start to buy it, and you start to produce more and more of them, well, you scale up production. You increase production, so you produce more and more of that item, and then consequently, the price can come down to 50 NT, even to 10 NT.
As fusion produces limited carbon emissions and nuclear waste, it could potentially be a source of clean energy. So the scientists, they're hoping that this nuclear fusion could be a new source of energy. So it's a new way to produce energy that we can all use, and it's clean for the environment because it creates less carbon emissions. So what's a carbon emission? When we burn fossil fuels, it creates a lot of other excess waste or other chemicals that go into our air, and it pollutes the air. So carbon emissions, to have emission is when something puts something out. So your car, it can emit smoke from the tailpipe because you're burning things in the engine. So there's other chemicals that are coming out of the car. So you're emitting these smokes, or you're emitting these chemicals.
Or these fumes, or this smoke, etc. So yes, indeed, we want to watch out for those carbon emissions. Here, carbon, of course, is an element, atomic number 6. And of course, we often talk about carbon monoxide or carbon dioxide, 2 different kinds of molecules that include carbon. And we've got the emissions here. Last year, I think I received something in the mail that reminded me that I needed to have the emissions on my scooter checked. And I went down to talk to my repairman, and he said, "Oh, you did it earlier this year. Don't worry about that. Your emissions have already been checked." But here, of course, we're talking about fusion, and it does not produce a lot of carbon emissions. Okay, it's probably good for the environment. Also, it does not create a lot of nuclear waste like nuclear fission does, and that might be good for the environment. It could potentially be a source of clean energy. Potential here just means the likelihood of something happening in the future. Hey, your kid is really good at the piano. He has the potential to become a great concert pianist. But here, potentially is an adverb, and we're talking about it being or becoming a potentially clean source of energy, which will not produce pollution, and prices will come down for electricity, and we probably could play on our phones for 24 hours instead of the current 18 hours.
Which also means that we have a potential to have an alternative choice of the energy that we receive. So there's a potential that we can have a different choice when we use electricity. And while the ultimate goal of large-scale nuclear fusion plants powering our lives remain far from realized, the recent breakthrough raises hopes for a greener future. So everyone's hope is that we hope that we can stop using fossil fuels. So that's why people have been looking at different types of ways to produce more energy, and that's why there's nuclear fission. And this time, finding out about nuclear fusion, scientists hope that the ultimate goal is to be able to produce more nuclear fusion plants, large-scale nuclear fusion plants. Okay, so a large scale is to have more of something or to make bigger quantities of something. So to have something at a large scale is you want to try to make this a norm. You want to try to have more power plants that are powered by nuclear fusion. And what is a plant? A plant, it's not a flower or a leafy vegetation in this case. In this case, plant is a factory that produces something or a factory that produces energy.
Right. So, of course, the places that produce power or electric power are called power plants. And here in Taiwan, we've got 3 nuclear power plants, 2 on the north coast and 1 down in Kending. And there's a controversial 4th one at Gongliao. We don't want to talk about that too much, but in any case here, we want to have these large-scale nuclear fusion plants that will power our lives, but that remains far from realized. If something's far from something, we have a long way to wait for that thing. So indeed, we do have that breakthrough, but that's going to be a long time before they actually can produce a lot of nuclear power based on nuclear fusion. We'll just have to wait and see. And again, though, this recent breakthrough raises hopes for a greener future and probably a cheaper future as well, since hydrogen is the most abundant element in the universe. Okay, that brings us to the end of our discussion for today. It's time now to listen to our Chinese teacher, Hanny.
各
位同学大家好，我是 Hanny。 我们来看今天的文法重点。课文一开始提到，数十年来科学家们努力要实现一项看似几乎不可能的壮举，也就是复制太阳和其他恒星产生能量的方式。好，那文中它用到单字 replicate 来表达复制，我们来学习它的字首字根。好，当我们看到 PLEX 或者是 PLE 或是 PLIC、PLI、PLOY、PLY 这一类字根呢，它们表示说折叠、对折或者是交错等等的意思。在 replicate 这个字当中，它的字首 re 表示 back 或是 again， 也就是有那种再次啊、再度回复回到原先状况的语义。那么字根 plic 表示折叠，那么 ate 是动词字尾。当我们把某个东西折回原本的样子，让它回到原先的状况，这样应该可以联想到 replicate 它有那种使重现啊、重复复制或是再生的意思。好，那也补充2个有相同字根的单字。第一个是 duplicate， 那它的字首 du 表示2或者是双，那么字根 plic 它表示折叠。ate 是动词字尾。当我们把一张纸对折，那你就会看到2层一样大小的纸张，这样应该很容易联想到 duplicate 这个动词，它有复制啊、拷贝的意思。那这个字呢，也可以当名词或形容词，不过这时候是念作 duplicate。那它当名词呢，就可以表达复制品啊、副本，或者是当形容词来形容复制的，完全一样的。好，那我们再补充另外一个是 complicate，它的字首 com 表示一起，那么字根 plic 表示折叠、交织、交错的意思。ate 是动词字尾，那当许多事物交织在一起，就会变得很复杂。complicate 这个动词呢，就表示使什么复杂化、难以理解。好，那我们接着读到课文第3部分的第1句，他说这种能量竞争益 net energy gain 让科学家希望核融合有朝一日能增加到帮助解决气候变迁的问题。那这边这个 net 在这边是当形容词，表示净得的。像我们说 net income 就可以表达净利啊、净收入的意思。好，在文中呢，它是用到 scale up 来表达增加。那么 scale 当名词，它有那种尺度、刻度、等级、比例等等的意思。不过在这边是当动词，我们用片语 scale up 就可以表达增大、扩大、增加、提高。那可以用在规模大小啊、数量或者是范围上。相反的用法，你可以用 scale down 或者是 scale back， 那就表示缩小、缩减。例如The company scaled back its production. 那间公司呢，缩减了它的生产量。好，以上是今天重点整理，我们回顾今天单字吧。
Laboratory. The science laboratory has special safety equipment in case an experiment causes a fire. Atom. Water is made from the combination of 2 hydrogen atoms with 1 oxygen atom. Laser. Mr. Bailey's doctor used a laser to remove his skin cancer. Hydrogen. Hydrogen is the most common element in the universe. Carbon. Carbon is a substance that forms coal and diamonds and is found in all living plants and animals. Emission. China and the United States are the countries that produce the most greenhouse gas emissions. Potentially. Lisa is so good at tennis that she could potentially be a professional someday. Breakthrough. The discovery of the bloody knife was a major breakthrough in the case.
Discussion starter starts now!
Here's our discussion starter for today. The question is, do you think that nuclear fusion will become a practical source of energy in the next 10 years? Why or why not?
Well, I think it's definitely possible. I think in theory, everything sounds picture perfect, something that doesn't create as much nuclear waste and, it limits the amount of carbon emissions. But I think to be able to set up all of these nuclear fusion power plants, it's going to take a lot of money and it's going to take a lot of time. It's just like we see all these solar panels and also the wind turbines. There's a lot of them, but it's still not enough to generate power to be able to provide electricity for everybody.
Yeah, even though it does seem rather exciting to have this breakthrough, I don't think that nuclear fusion will become a practical source of energy in the next 10 years. Given that you need to do this to many billions of hydrogen atoms that are larger than a peppercorn, so I think they've got a long way to go on that. And of course, there are probably going to be political problems that will prevent future research, lack of money or whatever. And maybe, of course, people will be opposed to it because, it sounds like it might result in a nuclear war. Well, that brings us to the end of another edition of our program, and please make sure you join us again next time. From all of us here, I am Roger.
I am Kiki.
See you next time.